This is for section 7 of Unit 23 for Workshop Physics, and I'm shooting this video to demonstrate measuring resistance, voltage, and current with a multimeter. If you're already familiar with doing this, obviously you don't need to know how to do the process, but you do need some numbers to record in your lab book. I do not believe the simulator that we've been using to answer many of these questions allows you to measure resistance with any sort of meter. I think the assumption is just that whatever value you set the resistance of the light bulb or the resistor to is whatever its resistance is considered to be. I also do not have a 10 ohm resistor as is specified in the book. Instead, I have one that I suspect is going to be about 33 ohms if the band markings are any indication. So we're going to go ahead and do part A, determine what settings to measure the actual resistance. So I've set my multimeter down here to the setting which measures a maximum resistance of 200 ohms. And then when the resistor does not have another electric current flowing through it, I'm going to hook it to the two leads of my multimeter to measure its resistance. And indeed, it comes out to a little over 33 ohms of resistance. Part 2 says determine what settings you need to measure the potential difference across a resistor in series with the battery. So I'm going to momentarily disconnect my meter and now hook my resistor to the battery using my two leads here. Now obviously can't really see anything happening, which is why we start generally studying circuits with light bulbs instead of resistors. And then to measure DC voltage, I'm using the upper left portion of my multimeter here, and I'm going to go to the 2 volt setting, and then clip on to my resistor and see what the voltage across the resistor comes out to be. Nothing. Alright, what's going on here? Wow, just like real life. And we get to troubleshoot a circuit. Alright, do I have good connections? No, I do not. The battery wasn't pressed up against the contacts here, and the positive end of my battery is here. I've got red in my common port on the multimeter. It doesn't really matter what wire conventions you use, but by convention, black is the common and red is the probe lead there. So this voltage across the resistor is coming out to 1.5 volts. The final thing I need to do is to measure the amount of current that's flowing in the system. Theoretically, I should be able to read it in milliamps, and so on these multimeters there's a milliamp setting. But to use a ammeter, analog or digital, I actually break a circuit at some point and insert the multimeter into here. Now, I have no idea if this is going to work. I haven't pre-tested this because that would require advanced preparation. Many of the low current settings on these digital ammeters are actually blown because people wire the ammeters incorrectly into the circuit when they're learning how to do so. So we will go ahead and find out if that's the case of this one. This one appears to be one that somebody has fried. Fortunately, there's a 10 amp setting on these multimeters, and most people do not kill that part of the multimeter. So we'll get at least an approximate reading here off of our multimeter of 0.03 of an amp of current.